So there is a theorem that see, look at this. There is a theorem that VU over PU plus VT over QT plus VS over RS is equal to 1. It's very, very much correct. So I'll work with this, then I will prove it later. So look at the one we are asked to find. We are asked to find PV write PV as PU minus VU. Yes, over PU, and we can write QV. Yes, as you can see, PV, PV is the same thing as subtracting VU plus PU. So that's what I did. So that same way, QV, look at QV, so it's the same as subtracting VT from QT. So I have QT minus VT over QT plus RV is now RS minus VS over RS. So what do you observe? We can write this as, since they have the same denominator, PU over PU is 1. So I have 1 minus VU over PU, yes, plus this is for this one, while this is 1 minus VT over QT plus 1 minus VS over RS. So what do you observe? We can factor this minus, we have minus VU over PU minus VT over QT minus VS over RS. So factoring, we add. Yes. So this is now equal to, we can factor the minus sign. This is equal to the 1 plus 1, that adding the ones, the 3 1 2 3. So we have 3 minus VU over PU plus VT over QT plus VS over RS. I will prove that this is equal to, as you can see, this is equal to 1. I will prove it later. So this is now 1. So I have 3 minus 1 is 2. So I've proved that. So let me prove how I got this formula, the one in red, this formula. So with that, we can see the solution is correct. Okay, to solve this, we use 2 major theorems. The first one is that the ratio of areas of 2 triangles with the same base equals the ratio of their height. Second, we use similar triangle. So let's add 2 auxiliary lines. So I've added 2 auxiliary lines. So let's call that, we're trying to compare triangle VQR and triangle VQR and triangle PQR. So this is the height of the first triangle. Let's call it H1, that's the small one, while the big one is H2. So let's call this point, this is 90. Let's call it ZY. So we have two similar triangles, that's two right triangles, VQZ and PUY. So we see that triangle VUZ is similar to triangle PUY. Yes, by right triangle similarity theorem, which implies that H1 over H2 will now be equal to the ratio of their hypotenuse. So the ratio of their heights will now be equal to, so similar triangle, now ratio of sides are proportional. So we have VU over PU. So we've noted that. So let's now, assuming we have the base, they have common base, let's call the common base of the triangle VQR and triangle PQR. Let's call the base A. So if you try to get the ratio of area, so we see that ratio of area of triangle VQR to that of PQR is now equal to half times the base A times the height, which is H1, over half times the base, which is A, times the height, which is H2. So we see that this is equal to H1 over H2. Yes, and we've gotten that H1 over H2 is the same as VU over PU. So using this combined theorem now, we can solve this, because as you can see, we have VU in the equation, we have VU over PU. So what are we trying to do? We now do the same for other two. That is, if you check, we have VQR, PQR, the same way we have VRP and PQR. So the same, now we do the same. We now see that ratio of area of VR triangle VRP to that of the big triangle, which is the same PQR, will also be VT over QT. Yes, and the last two triangles, which are triangle, so we have ratio of triangle ratio of triangle VPQ to that of the big one, which is triangle PQR, will be VS over RS. So what do you have to say? Remember, we're asked to find the sum of this, VU over PU plus, so adding this, therefore what we're asked to find, therefore VU over, let me use white, see that VU over PU plus VT over QT plus VS over RS will now be, so we've gotten that VU over PU is area of triangle, ratio of area of triangle VQR over area of triangle PQR plus area of triangle VRP over triangle PQR plus area of triangle VPQ over area of triangle PQR. So looking at this is now area of triangle PQR over area of triangle PQR, yes, which is now equal to 1. Do you know why? If you notice, the three have the same denominator, so that's why the denominator is area of triangle PQR. So the numerator is now area of VQR plus area of VRP plus area of VPQ. You get the logic? Yes, the numerator is now the addition of the numerators because we have the same denominator. And checking the addition is the same as will form the big triangle. Check. VQR is this, VRP is this part, while VPQ is the other part. So forming triangle PQR. That's why it's all they will all sum to triangle PQR. So we now have triangle PQR over triangle PQR, which is 1. So we've proved that. Thank you.